Cameron, tell us a bit about yourself.
My name's Cameron Keating. I'm from the USA. I've been manufacturing lithium-ion batteries for 13 years in both the United States and in China.
So Cameron, tell us what will happen to all of the components once they enter our doors in the future?
So components are first checked for incoming quality. Once they pass that inspection, then they'll move into a production area, which will be here in the future. So first, there's 3 areas to make a battery. There's the making of the electrodes, then the assembly of the stack, and finally formation. So we'll start just about here will be the mixers. And we have dedicated lines for both anode and cathode. So first we mix cathode and anode slurries in separate rooms. And important to mention, this is where we add the lithium powder as part of the cathode slurry. The slurry is coated onto copper or aluminum foil, and it goes through an oven, which is to dry off the liquid. And then we get to the dry side of the coater, we have a nice even coating of slurry on those films. After that, we move to calendering. And this is where we put the dry slurry coated on the film through 2 wheels at very high pressure.
Okay, and what does calendering achieve?
Calendering is very important to the process because we're increasing the density of the coated material on the films. And this is very important to the performance of the cell. We want the most contact as we can at a molecular level.
And all of this that we're talking about, it's happening in the temperature controlled dry rooms, right?
Absolutely. Moisture is our enemy. So all of the rooms here are kept at a dew point of at least minus 40 C in an effort to reduce how much moisture is in the battery.
What is the next step?
The next step is assembling the stack. So the first part of that is we need to take notches out of these rolls, which then get fed into magazines. And then we assemble these into a stack with a Z-fold. So cathode, anode with separator and a Z-fold in between. So then that stack is taken, placed into a pouch. That pouch is deep drawn from aluminum foil. Then that pouch is sealed up, and then we add electrolyte, which is the liquid that allows the lithium ions to shuttle back and forth between the anode and the cathode. At this point, we have a sealed battery that's almost complete.
Then we get to formation and aging, right? What is that good for?
Formation is the first time you pulse electricity through your cell. This is very important because there's chemical reaction that takes place to form an SEI layer, and this also sets the performance of your cell.
And Cameron, what type of battery formats are we going to be producing in this facility?
We plan to make both pouch cells and cylindrical cells here. So these are 2 different formats. Pouch cell is basically more of what I just described to you, of the stack being placed into a pouch. A cylindrical cell, we add a step where we slit the rolls into a much thinner roll, and then we wind them instead of Z-folding. And that wind, which we call a jelly roll, is inserted into a can. And that's a smaller format, but also still very useful in many industries.
So the audience could kind of imagine these 2 formats as a larger table of chocolate for the pouch cell and for the cylindrical one as the types of the batteries you put into your remote controls and other electronics, but a bit bigger.
Exactly.
I'm quite interested in the charge level of the batteries that leave this facility. So how do we approach that?
All our cells leave here at 30% SOC, or state of charge, which is a reasonable amount. It's a good balance between being a safe level of charge and also maintaining the quality of the cell during transportation and storage.
So I assume at the end there is some testing and the batteries are ready to go.
Of course, all our batteries will go through some extensive testing to make sure that they're leaving here at only the highest quality level.
Okay, so now we know how batteries are made. Cameron, thank you very much.
Thank you.